Hey, Jody here with weldingtipsandtricks.com. Let's do it. In this video, I'm going to be comparing a couple of different TIG cups on some aluminum lap joints. And I'll be doing this on an aluminum cube that I made in a previous video, just to get more out of the cube. If you want to see the outside corner welds on the cube, that's a whole separate video. You can find it pretty easily. Just look for this picture right here on YouTube. And if you're not on YouTube, I'll try to link it up. So I'm just putting them diagonally like this. I like to tack weld using a sharpened electrode, and then I let it kind of ball up however it will. But for tack welding, I get a little bit more crisp of a start. And also for tack welds, I like to use a smaller diameter filler metal, so that my tacks are smaller. When I come back over them, I can kind of totally weld over them without telling where they are. I'm going to get a tack weld on all four corners of this, and maybe even one or two more, and then just weld it out with a 332 2.4 millimeter 4043 filler metal. I'm using a Furic number 8 Pro clear cup here with about 20 CFH of argon, and a little bit later I will switch over to a different cup and we'll compare the different results. I've got my amperage set to about 140 on the machine and just using the foot pedal, and I would estimate that I'm somewhere around 120 amps for most of it. Of course, I'm going to be at a little bit more when it's cold and I'm trying to get the heat up, and then when I'm getting toward the end of a weld, I'll be backing up to less than that, but 120 amps on the average. I started experimenting with clear cups like this number 8 here to help me film this process, and you can see it's really helping us all see what's going on here. Even on trailing shots or on leading shots, you can look through the cup, which is really helpful when you're welding down into a corner or something like that. I find it just helpful in just helping me see better overall. And of course, helps me film something better for us all to watch and learn from. We'll weld a couple of more with this number 8 cup, and again, I'm at 20 CFH of argon. I've got the AC balance set to 67%. I'm on a Dynasty 280, and the AC frequency on 100 Hertz. I'm using the default soft square wave here. Again, amperage about 120. Trying to hold a fairly tight arc. Again, I'm using a 332 4043 electrode. Things are going okay. This is really clean metal. I mean, this is something I ordered from a company online. It was all sheared out, all sheared to size with a protective peel coat on one side. So basically I just removed the peel coat, gave it a wipe down with acetone, and then went to welding. Now there are certain jobs that you might want to go further than that on the cleanliness. You might want to actually go to the extent of a carbide burr or some type of carbide tool on those edges to get them perfectly clean, but it just depends on what you need. Sometimes it's not worth going through all that effort. Sometimes it is. It just depends on your customer or code requirements and things like that. Now I'm resting a TIG finger right here on this just to kind of demonstrate what you might do if you're welding on something that you can't spin around on the bench top. Also, a flex head torch helps in a situation like this to get the right angle that you want. Now I've got a different visual perspective on this joint. It looks completely different to me, a different line of sight, and so I'm trying to weld it at the same amperage, but after it was all done I could tell it's a little bit colder, like I probably welded it at about 5 less amps than I did the previous welds. It's still going in okay. I would call it still acceptable. It's still flowing into the root pretty good, but you can tell each one of those ripples is definitely more distinct than it was in some of the previous ones. So I'm going to correct that on the next shot. Wouldn't it be nice if you had a amperage display readout inside of your welding hood? It would really be helpful for things like this. It's coming. It'll be here before we know it. I'm doing the same thing here. I'm resting on my TIG finger. I'm trying to just glide along, move the torch ahead about 1/8 of an inch at a time, about once per second or so. Trying to feed the same amount of filler in there each time. So this one's going in a little bit nicer. The ripples are sort of blended together and not quite as distinct. Just a little bit more amperage made the difference here. Notice the frosty looking area at the toes of each weld there. That's a nice broad cleaning path there, and that's what you get with a number 8 cup like this with a gas lens. If you're looking for some nice, soft, yet durable TIG gloves, I got them now. I searched a long time. I finally found a source for these. They're really nice. I'm switching over to the Alley 5 kit clear cup now. I'm going to drop my argon down to about 15 CFH instead of 20. The amount of argon you need is mostly determined by the diameter, the inside diameter of the cup you're using. So you can use a factor of 2.2 and get right in the ballpark, but there are always exceptions. I say 2.2, so this is a 5 cup. If you were to multiply 5 times 2.2, you'd come up with 11. 11 would be enough flow for this little cup. But because sometimes I extend my electrode out a little bit farther for filming, I went ahead and bumped it up to about 15. I didn't change any of the settings on the machine. I didn't change the AC balance. I just put the smaller cup on and reduced the flow of argon a little bit. And you can see already a much more narrow band of cleaning action, also called cathodic etching. That's what breaks up the aluminum oxide on the surface of the weld and lets you have a clean puddle on aluminum when you're welding on alternating current. So this little cup does a great job on aluminum. It can save you a little bit of gas. It just depends on the application. Just depends on, like if I was welding a dirty casting, I probably wouldn't want to use the number 5. I would prefer going to the number 8 cup. On this close-up, you can tell there's hardly any cleaning action reaching outside the toe of the weld. Here's the Alley 5 cleaning action compared to the 8 Pro. A nice frosty look, a nice band there. Again, it just depends on the application, depends on what you're doing. Or sometimes it depends on the customer requirements. Here's a shot of a start of a weld and kind of looking through the cup almost at where I'm feeding wire. Another benefit of a clear cup, you don't always need that, but sometimes you do. Sometimes it's very helpful to be able to look through the cup. If you pay attention here, you might notice me raising and lowering the torch. I've shown this several times before, but basically I'm just using a really tight arc when I'm trying to push that metal into the root, and then raising as I feed the rod and the puddle grows in height so that I don't clean electrodes all day long. I'm pretty good at duffing an electrode, so that little technique has kind of proved useful for me. Now, I got a lot of lap joints on this cube, so I wanted to show lots of beginnings and ends and different angles, trailing shots and shots like this. And whenever I even edit this stuff, I learn something. Like I didn't realize I was overlapping the corner, the edge, quite as much as I was. Of course, this is magnified a couple of times here too, but you know, like maybe I don't need to overlap by that much, but aluminum beads tend to be a little bit bigger than you think sometimes. Another thing on aluminum, I add a little bit of extra rod and swirl as I taper off to prevent a little crater eye, which oftentimes actually is a crack or will turn into a crack. So you don't want that. Got to come up with a technique to prevent crater cracks on aluminum, that's for sure. A lot of times cracks initiate there and it'll turn out the whole part will fail eventually, all from one little star crack that started off as a crater dot. But it doesn't matter how pretty your weld is if the thing fails because you left a crater and it cracked. One of the best things I've learned about using these clear cups is they just tend to light up the whole area around the bead. You can see where you're going, you can see through the cup. I find it very beneficial for me with my eyes not being quite what they were when I was 21. So you're the least little bit interested in learning more about the clear cups as well as my TIG fingers, TIG gloves, TIG accessories, all kinds of stuff. Visit weldmonger.com. That's how I support these videos. Thanks so much. See you next time.